A building is made by cutting large trees into small pieces and then joining these pieces in the ways we want them. To join the pieces of timber together, we use fasteners. Withdrawal strength refers to the amount of effort needed to pull a fastener out of timber. The more effort required to pull a fastener out of a particular wood, the higher its withdrawal strength. The withdrawal strength of a particular timber depends on two factors: whether the fastener is driven into the end grain of the wood or the side grain, and the density of the wood. These are three different types of wood, and each have a different density. We can see this when we put them in water. The denser the wood, the more it sinks. Willow is the least dense of the three. Cherry is medium density, and this eucalyptus is almost as dense as water, just under 1,000 kilograms per cubic meter. The denser the wood, the harder it is to drive a nail in. But it's also harder to pull the nail out as well. Hence, the denser the wood, the higher the withdrawal strength and the stronger the join. Withdrawal strength is also affected by whether the nail is driven into the end grain of the wood or the side grain. In softwoods such as this willow, a nail that is driven into the end will have only 50% of the withdrawal strength of a nail driven into the side grain. In medium density wood such as this cherry, a nail driven in the end grain will have 60% of the withdrawal strength of a nail driven into the side grain. In a dense wood, such as this eucalyptus, the withdrawal strength of a nail in the end grain is 75% of the side grain nail. Bending the end of the nails is called clinching. It increases the withdrawal resistance dramatically. A clinched nail can be 2 to 5 times harder to withdraw than a normal nail. This one pulled the head through. The nailing characteristics of plywood are not greatly different from those of solid wood, except that plywood splits differently when nails are driven in near an edge. Solid wood splits much more easily. Plywood splits differently because plywood is made up of layers of wood that have grains running across each other. In both examples, you need to drill a lead hole if you are near the edge. Plywood has about 20% less withdrawal strength than solid wood of the same thickness. Drilling a lead hole reduces splitting of the wood and raises the withdrawal strength. This nail goes straight in with no problems. It is going into a lead hole. This nail does not have a lead hole and the timber splits. Lead holes are usually 90% of the nail's diameter. They produce greater withdrawal resistance than nails hammered straight in. A drift bolt is really a large nail driven into a pre-drilled hole. In hardwood, the hole is 1 millimeter smaller than the bolt. In softwood, the hole is 3 millimeters smaller than the bolt. The drift bolt is a long pin of iron or steel and without a head or point. They are mainly used for joining large pieces such as railway sleepers. The hole is longer than the bolt. It produces what is known as a pin joint. Although it can be easily rotated, it is strong in shear and has good withdrawal strength. Screws, like everything else, come in different shapes and sizes. The heads may have a straight cut, a Phillips head, a square or hexagonal hole, or a hexagonal bolt head. Tapping screws have threads the full length of the shank. These are useful for thin materials. A flathead screw is most commonly used if a flush surface is desired. Flatheads are no use if they can't be countersunk. So they are no good for sheets of iron, for example. Roundhead screws have a flat underside and are used for thin material. Large screws are driven into pre-drilled holes and cut their own thread into the sides. The size of the hole is a matter of judgment, and it may take a few trials to get it right. If the hole is too small, the wood will split or the head will twist off.
Now look at the thread inside.
The big advantage that screws have over nails is that they can be removed easily without damaging the wood or the fastener. There's no sense in using a long screw in a hard or dense wood, as the screw will break. If you are using a drill with a clutch, it will stop before the screw breaks. The strongest screws in building are the batten screws. They have revolutionized building. Here they are being used to hold roof battens down against the wind. The withdrawal resistance of wood screws varies with the square of the density of the wood. So if the wood is twice as dense, the withdrawal resistance of the screw is 4 times greater. The withdrawal load also increases directly with the length of the screw and its diameter. So a thick, long screw has greater withdrawal strength than a short, thin screw. So if you want to make a joint twice as strong, use a screw that is twice as long or twice as wide. To make the joint 4 times stronger, use a screw that is twice as long and twice as wide, or use wood twice as dense. A screw will fail when its strength is exceeded by the withdrawal strength of the wood. So there is no sense in using a long screw in hard or dense wood because the screw will break. Bolts are known as threaded fasteners. They have a few advantages. They are very strong and easy to undo. They are good for prefabricated work. Tightening a bolt is known as post-tensioning because the bolt is tensioned after the work is assembled. The bolt holds the work tightly together. It takes a large load before the joint will crack open. In wood, bolts must always be used with washers to spread the load and prevent damage during tightening. A long threaded bar is called a stair bolt because it is used to hold stairs together. Here it is used on a refractory table to hold the horizontal members tightly onto the leg. Even if a large load opens the joint, the bolt will stretch slightly, then when the load is released, we'll pull the pieces back into place and close the join. A glued join would fail in this case. Normally, when making a frame, the nail is driven in from the outside, but if this isn't possible, the nail can be driven in from the inside at an angle. This is called skew nailing. To get the strongest join possible, use the largest nail that you can that doesn't split the wood.
Now pull it back.
Nails are started 1/3 the length of the nail from the end and driven in at 30 degrees. The full shank of the nail is driven in. You must take care not to damage the wood with a hammer, so get the nail in as far as you can and then finish it off with a nail punch. Nails can be slippery little devils and quite hard to drive in. If you roughen the end of the hammer with emery paper or a brick, it will be much easier. The other trick is to oil the nail to reduce friction. If the wood is held firmly, it is straightforward. If the wood is loose, it can be very difficult. As a rule, half the nail into each piece of wood gives optimum results. Skew nails are stronger than straight nails and can be used in a number of different ways. These days, builders use nail guns to do the repetitive job of nailing. Hand nailing is only done in one-off or tricky situations. Before using one, you need to carry out a basic safety check.
Check the return spring on the clip, the tension clip.
Load the nails into the gun. Release the tension clip.
Okay, release the tension.
The nails are now secured in the gun. Check the air hose coupling, hose, and see if anything is damaged. Then check the timber for holes or knots that can fall out of the wood. Nails fired through holes in timber have killed people. This one missed the stud. The air pressure here wasn't high enough for this one, so it must be increased. This air pressure was too high and the nail has split the wood. It could pass right through the wood and hit someone. One of the beauties of a nail gun is that it can nail loose pieces that would be nearly impossible by hand. The nails are flattened on one side so they can fit into a belt and not be caught when fired. As wind can rip a roof off, the challenge is to hold the roof down. A skew nail into the end grain of softwood is not strong enough. This tie-down is a knuckle plate. It is far better than nails because it requires much more force to withdraw the knuckle plate sideways than a nail driven into the end grain.
Degrees. Okay, so we've the walls are placed flush on the outside. We're fixing block. The knuckle plate.
The same principle applies to these knuckle plates. The force is sideways.
This will secure the joint. Okay, we then start nailing the nails.
All of the prongs have to be driven in. Nail plates are connectors with holes for nails that have been designed for joining wood at angles. They use nails like this. The connectors have been designed to have nails in all holes. This is a multi-grip. It comes in left and right-hand configurations. It can be used to join pieces at a variety of angles.
So, place the multi-grip, left-hand application.
For a lattice, staples are driven with a gun. Staples are used on thin sheets. Fascia boards require thin, galvanized nails. Usually they are skew-nailed. Once again, finish off with a nail punch so that you don't damage the surface. You'll need to fill the holes with putty to prevent water damage. Skew nailing can be done with a nail gun as well. Again, putty the nail holes. Before weatherboard can be fixed, the flashing needs to be in place to keep everything waterproof. The nails need to be as thin as possible to prevent splitting, which would allow water to seep in. The same principles apply to internal lining. Thin nails with a little extra grease hammered in carefully. It's much easier with a nail gun.